Hello everyone, I welcome you all to Startup Academy, India's exclusive coaching for ISS examination. In today's lecture, we'll be starting with a new topic which is order statistics in statistical inference. So, what do you mean by order statistics? We'll be discussing what is order statistics and PDF distribution function, everything about order statistics. Suppose we have a random variable xi where I goes from 1, 2 up till n, and all the i's are IID, identical and independently distributed random variables. Suppose all i's are that. If I arrange all the i's according in ascending order, x is in ascending order. Suppose the first one is x1, the second at second position is x2, then at third position it is x3, and so on up till the last position is xn. When I arrange all of them in ascending order, then this process is known as our order statistics, where x1 is the smallest of all the x1, x2 up till xn is the largest, and this. So this is known as our order statistics, and it is very important according to examination point of view. But since here we have put this inequality sign, so these does not remain independent, they depend on each other, and hence this is known as order statistics. Let me show you that x1 is the smallest observation among xi's for all I goes from 1 to n. If we talk about xn, it is the largest observation among all xi's for all I goes from 1 to n. And if we take randomly, if I am taking xr, then it is the rth smallest observation among xi's for all I goes from 1 to n. Rth means if I take r is equals to 3, then it will be third smallest observation. If I take r is equals to 20, then it will be 20th smallest observation among all i's. So this is our order statistics. This is what we discuss in order statistics. Now we'll be discussing about x1, x2 and xr. So first of all, let us discuss about the largest observation, which is nothing but xn. So if we have to see that all of these x1, x2, xi have PDF fx, common PDF fx, and common distribution function capital Fx. This we have to consider before taking that. So the largest observation has the PDF. The PDF of the largest observation will be fn x. This is not the PDF, this is the distribution function. Capital Fnx is the distribution function of the largest observation xn, where it is nothing but, the formula is nothing but probability that xn is less than equal to x, which opens up to fx whole raised to the power n. This is our distribution function of largest observation. If we talk about the PDF of largest observation, it will be denoted as fnx is equals to the probability density function is the differentiation with respect to x. Here we are taking x with respect to x of our distribution function. So it will be the differentiation of this, it will be n f x raised to the power n minus 1, and distribution of fx will small fx. This will be our probability density function of x n, the largest observation among the order statistics. Okay, now we move forward to the smallest observation. Which is nothing but x1. If we talk about the distribution function of the smallest observation, it will be denoted by capital F1 x, that should be equal to probability that x1 is less than equal to x, which can also be written as 1 minus f x raised to the power n. This is our distribution function for the smallest observation. If I tell you about the PDF of smallest observation, then it will be denoted by f1x is equals to, differentiation of this will be n 1 minus fx raised to the power n minus 1 with the minus sign. But if we differentiate capital Fx, it will also come with the minus sign, minus small fx. So this minus and this minus will get cancelled, and we'll be getting our answer as positive only. This is in multiplication. This is our PDF for smallest observation x1. Okay, and if we have to find out the PDF of xrth observation, PDF of rth observation in the order statistics, which is denoted by xr. If we have to calculate that, there is a direct formula. I'm telling you that it is f r x is equals to 1 upon beta r n minus r plus 1 into fx raised to the power r minus 1 raised to the power r minus 1 small fx into 1 minus capital Fx raised to the power n minus r. This is the direct formula. You just need to mug it up. Don't need for derivation of this. Okay. Now, these were some of the properties or the direct relations or that we observe or that we use in solving the questions of uh, this order statistics. Anything else that will come in the question, I'll tell you then and there. Let us move towards the questions. Now, the first question is not directly related to this observation thing, order statistic. This will be for the two lists have been provided to us. First list is of distribution and second list is of MGFs, moment generating function, and we have to match them. So first of all, there has been they have given us exponential distribution. The second one is Cauchy. Third one is normal, and fourth one is Poisson. Okay, so exponential distribution, as we all know, has the MGF as 1 upon 1 minus t. If we talk about exponential distribution, for all t is less than 1. So this matches our option number 4. Okay, so A matches with option number 4. Wherever A matches with in option number A and B, A matches with 1, it is wrong. If we talk about Cauchy distribution, the MGF does not exist. So for this, B matches with option number 1. So in both of them, B matches with option number 1. We have to check another one. If we talk about the normal distribution, it is e raised to the power t square for all real t. For normal distribution, MGF is this. That means C matches with option number 3. C, C matches with option number 2. Here, in option number C matches with option number 2 and D matches with option number 3. Here it matches with 3, which is wrong. So our C option is correct. Let us see the last one as well. For Poisson distribution, it will be e raised to the power et minus 1. This is for all real t. So our this is our option number 3, and hence our C option is the correct answer. Right? Now moving forward to another question. This is very important question. This is lack of memory property. What is lack of memory property? If you're talking about lack of memory, that suppose I am conducting a a conditional probability, then I should be having the previous probabilities in order to conduct that conditional probability. But some distribution do not have any relation with the previous one. In discrete distribution and in continuous distribution. In discrete distribution, the one that does not follow our lack of memory property is uh, geometric distribution, and it continuous, it is exponential distribution. So these two distribution you have to keep in mind that does not follow lack of memory property, and that possess lack of memory property, and hence our option number C is the correct answer. Geometric distribution or exponential distribution. Now moving forward to one of the important question for today. Here they have provided us that x1, x2 up till xn is a random sample from a distribution with probability density function fx. They have provided us with probability density function fx and distribution function as capital Fx. And the PDF of range, here it is xn minus x1. So they have provided us range which is x, the largest observation, minus the lowest observation. You just need to know the formula. I am telling you directly. The formula for order statistics range is nothing but if we have to calculate FW, if W is denoting the range, then it will be n minus 1 integration minus infinity to infinity bracket fx into fx plus w minus fx bracket close whole raised to the power n minus 2 into fx plus w dx for all w is greater than 0. This is our formula for range of order statistics, which matches our option number C in this question. And it is very important. They will just ask you the formula, so you should know the formula and the kind of options they have given, you know that. Okay. Now moving forward to another question. This is one of your PYQs of ISS. They have given us what is the probability that the sample median is based on a sample size of n. See here, sample size is of 3. So median will lie in between 3, which is 1.5, but we cannot take 1.5 because in order statistics we only have whole numbers 1, 2 and 3. So the median will be 2. So our rth order statistics will be 2. And they have given us the PDF, which is fx, which is equals to 2x for all 0, x lies between 0 and 1. So first of all, we'll calculate our distribution function. If we have to calculate distribution function, it will be from 0 to x, fx, fx. Instead of fx, we'll be taking fu, which will be 2u du. If we integrate it, we'll be getting our answer as x square. So we have got our distribution function, we have our PDF. Now the formula for rth order statistic is, PDF of rth order statistic is f r. Here r is equals to 2x is nothing but equal to, I have told you in this, 1 upon beta r n minus r plus 1 fx raised to the power n minus 1 small fx 1 minus capital Fx raised to the power n minus r. So we will be putting directly here 1 upon beta r is 2, n minus r, 3 minus 2 will be 1, plus 1 will be 2, beta 2 comma 2 into fx, capital Fx, which is x square raised to the power r minus 1, which is 2 minus 1, small fx, which is 2x, and 1 minus capital Fx, 1 minus x square raised to the power n minus r, which is 3 minus 2. If we solve this, beta 2 upon 2 will be 1 upon 6, which will get multiplied in the numerator, and 1 upon 6 will get multiplied to 2 will be 12. 12x cube 1 minus x square. This is your PDF for the median. Now they have asked us what is the distribution of the PDF which exceeds 1 by 2. So the probability that PDF is exceeding 1 by 2, because this is continuous, so it will be from 1 by 2, and the largest range of x is 1. So from 1 by 2 to 1, the PDF is 12x cube 1 minus x square dx. So it will be 12 will get outside. If we integrate x cube, it will be x raised to the power 4 upon 4 minus x cube into x square will be x raised to the power 5. So if we integrate it, it will be x raised to the power 6 upon 6 with the range 1 and half. When we solve all of this, we'll be getting our answer as 27 upon 32, which is our option number C. So this kind of question is a bit difficult and has been asked twice in your examination in 2019 and 17. Okay, so this is how we solve this. I hope that this question is clear. It was a bit tough and I haven't done small calculation that you can do. I have just made you realize what is the concept and you can do it on your own. Now moving forward to another question. Here this is also one of your PYQs. Here they have asked, let x1, x2, xn. So there are total number n, 5 numbers have been given of independent observation from a continuous distribution. With distribution function they have given us as capital Fx, and PDF they have given us as small fx. What is the probability density function of a sample mean? For a sample median, that should lie in between among 5, and since it is a whole number, so in between 5 it will be 2.5, and 2.5 converted to nearest whole number will be 3. So our r will be equal to 3. Now the formula for the PDF of rth distribution, f3x will be equal to fx whole raised to the power r minus 1 into small fx into 1 minus fx whole raised to the power n minus r. So just putting the terms, fx raised to the power r minus 1, r is 3, 3 minus 1 is equal to 2, small fx is multiplied, then 1 minus fx whole raised to the power n minus r. N is 5, r is 3, so 5 minus 3 will be 2. So this matches our option number, and that it is also multiplied by 1 upon beta r. R is 3, n minus r, 5 minus 3 will be 2 plus 1, beta 3 comma 3. It will also be multiplied by beta r n minus r plus 1. So beta 3 comma 3, I can show you how to solve it. Beta 3 comma 3. It will be gamma 3 into gamma 3 upon gamma 3 plus 3, which will be 6. So gamma 3 is 2 factorial, gamma 3 is 2 factorial, gamma 3 is 2 factorial, and gamma 6 is 5 factorial. Instead of 5, I can write it 5, 4, 3 into 2 factorial. So this will get cancelled, 2 will get cancelled with 4, and we'll be left with 1 upon 30. So beta 3 comma 3 is 1 upon 30. 1 upon beta 3 comma 3 will be 30. So 30 will get multiplied here, and this will be your final answer. Only one term, option number D, has 30 in here, or rest other has 5. So all of them are cancelled. This is your final answer for this question. Now moving forward to another question. Here they have given us the rth order statistics is XR, and in a random sample of size small n from a distribution with CDF, the distribution function or the cumulative distribution function they have provided us with fx, and what is which is continuous, then fxr. So they want to know about the CDF of the rth observation. This thing they want to know us about. It follows which are its order statistics. It is easier, it is not complicated. See, whenever we talk about any CDF, if we are talking about any CDF, then it always lies between the range 0 and 1. It does not lie after 1, it does not lie below 0. It is for normal statistics. But when we are talking about the statistics, the rth statistics, rth order statistics, it will always lie between 0 and 1. So here let us see which distribution has range 0 and 1. The first one has the range -1 and to 1, so it will get cancelled because it is going beyond 0. In the second one has 0 and 1, so this can be the case. Let us keep it aside. Normal distribution has the range of x minus infinity to infinity, so this is also cancelled. And exponential distribution has the range 0 to infinity, so this is also get cancelled. So our option number B is the correct answer, where the uniform distribution has the range over 0 and 1. This is your answer. Here logic is used, no such concept of order statics has been used. From logic only we can solve this, and this came in your examination in 2020. So that's all for today's class. I hope that I was able to make you understand the topic clearly, and if you're facing any doubt, then you can ask us in the comment section or on our WhatsApp channel. Only relevant doubts will be answered. All the best. Thank you.
Startup Academy presents Lakshya 2027, an exclusive batch designed only for serious ISS aspirants.